Hello and welcome everyone to my channel Code with Ease by Varsha. We have been doing the 2D array series for some time now. So as part of that, today we are going to cover how to search a 2D matrix. In this, we are not only going to understand the implementation of 2D arrays, how to work with 2D arrays, but we are also going to see how to apply binary search algorithm to the 2D arrays. We have already done quite a few questions under the binary search question series. I would highly recommend to check out the playlist in the description. Okay, so now let's look at the problem statement. Write an efficient algorithm that searches for a value target in a m cross n integer matrix. The matrix has the following properties. The integers in each row are sorted from left to right, which means there's a sorted matrix. The first integer of each row is greater than the last integer of the previous row. Okay, so it's like it's in a continuous sequence. If you see this example, it's in sorted, so 1, 3, 5, 7. Then after 7, the next greater element is 10. So it is not like every row is sorted alone. It's like the entire matrix is sorted and it is all the elements are going in a continuous order. So this is how it is 10, 11, 16, 20. Now the goal over here is, given this kind of a matrix, we have to search for an element. So far we have applied binary search algorithm to 1D arrays, in which given an array we were trying to search for the target element, trying to find the position of the element and all of that. But in this case we have a 2D array, a two-dimensional array, and we have to search for an element in this array or the matrix, and then we have to return a boolean true or false. So that is all about this question. Since it is already mentioned that the array, the matrix is sorted, and we have to write an efficient algorithm, so it's a clear indication that we have to use binary search. Now we have to figure out how can we apply binary search in the most optimal manner so that we can search for the target value. Okay, so we'll discuss the approach for solving this. So here is the array that we have taken, sorted continuously 2, 3, 4, 5, 7, 9, 10, 12, 14. Is it something like we're going to apply binary search in every individual row of the array, or we can try to optimize in finding which row can tentatively contain the target that I am looking for. So let's say the target is in this case 12 that we are looking for. Okay. So the approach should be something like find first of all which row can contain our target, right? Because we are not going to blindly search in every row. If we are doing that, it doesn't make sense. I mean, it is something similar to linear search only. We are checking every element, we are checking every row. Doesn't make sense. We have to find out which row can contain the target, like find out the exact row which can contain the target. And then, of course, when you have the row, find the element in that row. These are the two steps. So given this array of length 3, find out which row can contain the element. So to do this only, we are going to apply some approach to this. So as we know, these are the row numbers 0, 1, 2 and 0, and so these are the row numbers 0, 1 and 2 for length equal to 3. Okay, so now if you have to pinpoint the exact row in which we have to find out which row can contain the target, here also we'll apply the binary search logic. What we do in our usual binary search algorithm, we have this low and high pointers, and inside that while loop we try to find out the mid, and with respect to that mid we write all the conditions. Correct. Something similar we are going to do. We also are going to find out the mid. Mid means here the length is 3, so 3 by 2, 1. So ARR of mid, so in this case ARR 1 of 0. So what we will do basically is we will just get the midpoint, means the middle row, you can say. This middle row's 0th column means the first element. We will check whether the target is actually greater than this, okay, and which means I'm saying that whether the target is greater than the first element of the middle row, and if the target is lesser than the last element. So how are we going to denote the last element? Same thing, ARR mid of n minus 1. First of all, what is the first point is to find out the middle row. So from this we can find out the middle row. So once we get the middle row, we check if the element lies in this range, greater than the first element and lesser than the last element. If this condition is true, if this is true, then we can search in this range, in this row. This is the row in which we are going to search. So this is going to be condition number 1. First thing we have to check. So this is like the ideal scenario. Other thing, what can happen? This will not be true, okay. So what other things can happen? The target might be greater than this element. So the target can be lesser than, not greater, lesser than this, lesser than ARR mid of 0. And since we know it is in a continuous sequence, if the target is lesser than 5, we have to look in the above row. In the above row means if the low is over here, low equal to 0 and high equal to here. So low and high are like the the starting row and the ending row. We will search in the first row. In that case, what we have to do, manipulate the high pointer. So we'll manipulate the high pointer. High is equal to mid minus 1. And else, the third scenario or the third condition, if not lesser than this, then obviously it will be greater. So we have to check in the last row, in which we have to manipulate the low pointer. Low equal to mid plus. This is like plain and simple binary search condition, same as that, nothing new, nothing complex. But it is just that how we are placing the conditions is different. So when I say search, this part, when I say in the first condition search, this is basically going to be this part, that find the element in the row, because this is plain and simple binary search in which we will do. We are going to write the method of the logic of the binary search algorithm and put it under inside this method, because when I say find the element in that row, once we have already figured out which row the element can contain, we can simply do a binary search in that row, just as we were doing binary search over a 1D array. But the trick over here initially is to find out which row can contain. Once you know that this row can contain, you just have to apply binary search to it. Okay, now other condition, let's say none of these conditions are satisfied, means the target is not present, so we can return false, because we are anyway returning boolean over here. Possible? Okay. And yeah, so that is all about the approach. So in this case, what is going to happen? First of all, this condition will become false because 12 is neither greater than 5 nor lesser than 9. So it will come over here. Is it lesser than 5? No, it is not. Is it greater than, it will of course come to the else part. Then low will be equal to mid plus 1. So now low will be mid is 1. So low will become 2. And high will be, anyway, high was over here only at the last row. So then now what is the new mid that is going to be calculated? Mid is also going to be 2 only. So it will be checked whether ARR 2 of 0 means this element, if 12 lies in this range or not. So in this we have 12. In the last row we do have 12. So then we will apply binary search in this row and find out the index position. We don't have to find out index position, we just have to return true. That's it. Simple. So that is all about the approach for this. Now let's write the code for this. Okay, so we'll start with the code changes now. So first of all, we'll define the low and the high pointer. So as we know, the first step is to determine which row can be the tentative row. So low will be equal to 0 because it's anyway starts from 0, and the high pointer in this case is going to be the number of rows minus 1. So we'll also take a variable to determine how many rows are there. It's going to be matrix.length, which is going to give us the number of rows. And high we are going to set it to n minus 1. So it is going to something like, if the number of rows are 4, so we are going to run from 0 to 3. 0, 1, 2, 3, 4 rows. With that, now let's run the while loop, the traditional binary search. We'll calculate the mid over here. Okay, so now the main condition. In this, we are going to check whether the given target lies in the certain range. So once we have got the mid, here mid is going to signify the middle row. So when we have the middle row, in this case, if they see this example, this is the middle row. So in this, what we'll check whether the target lies in this range. So what we will see, if target is greater than matrix of mid 0. Why mid 0? Because if it is row number 1, so the index position of this is going to be 1, 0, 1, 1, 1, 2, 1, 3. If this is greater than this and target is lesser than matrix of, going to be mid and then the column number. Okay, so the rows and column numbers are different. So matrix.length gives us how many number of rows are there, whereas if you want to get the number of columns, we have to define a different variable to do that. So let's do that over here. Let's call it number of columns, and that is going to be matrix of 0 dot length. So for that, for any given row, how many columns are there? So if the column number of columns is 4, like we have in this diagram, means the column number, the last number is 3. So it is going to be columns minus 1. So if this condition is true, then what we have to do? Then we have to start looking in this range. So we will write the binary, we'll call this binary search in 1D. Let's say there's a method we call. And then whatever this method is going to return, that is what we are going to return. So we'll make sure this method also returns a boolean value. So this method we are going to implement. This is going to be the plain and simple binary search logic. Within this, we are going to pass in the parameters. So in this, we'll pass in whatever the target value we are looking for. Then we have to also pass in the array. So what is going to be the array in this case? The matrix of mid. Why? Mid is again the middle row. So in this case, 0, 1, 2. Matrix of mid is what? For this row, whatever the array against it is there, whatever the 1D array against it is there, that is going to be the 1D array on which we have to do a binary search. So that array we have passed in the target also. So this is the thing when we have actually found the right row in which the target is supposed to be there. Okay, what else can we check? Now if that is not the case, then what else can we do? If the target is lesser than matrix of mid 0, means if the target is lesser than 10, means any of these, any number which is less than 10. So in that case, we have to adjust the high pointer. So the high is going to be mid minus 1, will make the high pointer move up. Otherwise, what else are we left with? That might be lying in the lower half of the array or the matrix, and that is why we are going to manipulate the low point, mid plus 1. That's it. Now we'll write the implementation for this method. Not going to type the code for this binary search 1D arrays because it is just the same code. Will be okay. So I've already written the code for this binary search 1D. It's the same old code for binary search. The only difference is, in case of traditional binary search, we don't return a boolean. We usually return the index value and we return -1 if it is not found. But it's just that since we are going to return a boolean, so I made it to true, and if it is not found, I made this to false. Now coming back to this, so if this condition is satisfied, we are anyway going to return this. Now let's say if this doesn't happen, I mean to say that if this condition doesn't execute, so obviously we will have to return something, right? So neither of them is, so if it is not even found in that 1D array, so finally what we have to return is, it's a boolean value, so we have to return false. So if it is at all not found in the matrix, the target is not found. So if at all the target is not found in the matrix, we'll return false. So that's all about this. Let's run this. uh, Incompatible target. Okay, the order is different. Just put the target. We'll submit this. Okay, it's a wrong answer. Okay, so it seems like an edge case. If there is one element only, so mid is going to be that index itself. Is the target 1 greater than this unless then this? 1 is not greater than this. Okay. Okay, I get it. It's not like a, so this check, what we have put is, we have to put equals over here, so it has to be greater than equal to and then lesser than equal to. Hope this works. Run this. Okay, so yeah, that was the miss that we have to check it. So yeah, that was the miss. We have to make it like greater than equal to, and it's like inclusive range we have to check in. So yeah, that is all about this question, how to search for an element in a 2D matrix using binary search. And hope you guys have enjoyed the session for today. If you're looking forward to more questions on binary search like this, you can let me know in the comments. And also please subscribe to the channel if you haven't already, and press the bell icon next to the button so that you get an update whenever we post a new video. So thank you so much for watching.